mapping the gray circle on the world map by using mathematical formula with the XY plane. This is not the parallel graph, but mathematics. Mathematics, the XY plane and X equal um, A, X equal the distance of from the distance of prime meridian, and then Y equal the distance of the angle, distance angle from 0 to 90, then X equal from 0 to 180, and Y equal 0 to 90. Then the map exactly the same. The map frame is from 360 for X and 180 for Y. And using the calculation between A and B with the same latitudes, and then making small program to mark vertex V with the A to B, A to V, V to B with the red line, and the other line for green line of gray circle. The shortest path is rarely a straight line. Long line is and that good line that is a small circle, but there has the ratio of the circle is higher than gray circle. Then it's a longer distance than gray circle. The gray circle is the shortest between A and B by using mathematical. So, and when we ask from A to B, so A with the same latitude, for example, we go for A is 37 northern hemisphere and 90 the east, 90, and B equals 37 northern hemisphere is 127. Then we can get vertex by using Napier's rules. And also we know about that longitude, that longitude, the distance from A to B directly longitude, and then divide by 2 is so. And you can get a GPS of the vertex, latitude, and longitude. Then you can mark on the map the vertex, and also draw the red line from A to V, V to B. On a curve, the shortest distance between 2 points on the exact same latitude is never a horizontal straight line, but now we see 3D map already, the first. And then we can show up from the 3D to 2D, means and the Earth globe to the plane world, anatomy of a spherical root, and point A to B with the same latitude, and then the vertex, we can measure vertex, and then we can mark the exact, not the anywhere, the exact point with the mathematical calculation. The root has the latitude point and vertex of latitude, vertex of longitude. Then we can mark on the map with the program by using Python something calculation from A and B. You can calculate the distance of longitude, and then you can find the distance of angle, the arcsin formula, get a vertex, or latitude vertex with the Napier's rule, and go for map, measure, mark the vertex, draw the vertex line from A to B, including B. And then the red line. The other line of the break circle is the green line, will be better. Select map projection from the GPS to screen pixel XY render route. Calculating the central angles. It's an easy way. Mathematical demonstration. And then the distance of delta. Gamma is longitude. Find longitude difference. The longitude, second longitude minus the first longitude will be the length of the angle of longitude and divide by 2 and get a longitude of the vertex. Calculating central angle is distance of angle. Central angle is arcsin, sine, square, plus cosine, square, cosine, gamma. Arc for inside. Because points A and B share the exact same latitude, we bypass complex spiritual cosine. This is simply that drastically simplify the calculation of the true distance equal R radius and the distance angle. Pinpoint the vertex, mark the V with the vertex on the map with the calculation of mass XY plane. X equal A, Y equal B. 예. 예, 거기 문 앞에 있어요. 바로 옆에 문이, 아니요, 그냥 거기 옆에. 예. Vertex longitude. Perfectly symmetrical exactly halfway between A and B. Mathematical peak of the curve. Tangent, pi, cosine, delta, gamma, divided by 2. Generating the full arc battery. We cannot simply draw a straight line making A, B, B on the map with the red line. Not the we must generate a continuous array of integrate to the geographic waypoints. 네, 고맙습니다. 네. Can mark V on the map exactly from X equal minus 180 to 180, Y equal 92 minus 90. The wave flow of programming for great circle route. Input coordinate, calculate for matrix using Python. Generate root array, interpolate intermediate waypoint, execute transformation, XY projection loop, and the mapping, render visualization, draw map, where line, doing routes, we do great circle, exact point, we do X and Y. Implementing the logic, spherical calculation with the Python. Then making program showing up. Hopefully implementing the logic arc interpretation fractional progression, the loop programmatically execute the fraction parameter from 0 to 1, populating step by step, coordinate a panning or fire, or is for smooth rendering. Not a growth, but XY plane with the world map, and we can directly understand about the razor prelude and the exact vertex, accurate mark at the calculated mathematical maximum latitude, visualizing the algorithm output by random results. Architecture takeaways, critical tools, symmetrical advantage, universal scalability. Okay.